Alright everybody, Mr. Carlson here, and in this video what I want to do is just take a look at the basic setup of the periodic table and just go through some terms and things that we're going to need to know as we move forward in this chapter. So the first thing is this. When we look at the periodic table, all the elements are arranged in these columns here, or in what are called groups. So if you look up at the top, across the top of each column here, there is a number at the top of each one. And this number right here, we refer to as the group number. The group number. So in other words, right here, group 1, we have all of these elements here would be considered group 1 elements: hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. All these are group 1 elements, and we could keep going down the line. Here we've got group number 2, which has beryllium, magnesium, calcium, strontium, barium, radium. All these are group 2. So on and so forth as we move down, all the way down to our last one here, group 18, which remember we talked about. This is the noble gases. All of these are in group 18. Okay, so group numbers, that's what these numbers are. These are the group numbers at the very top, and it refers to that column of elements there. The other thing that we need to be aware of are, and I didn't leave myself a lot of room here, but if we look over here on some of the periodic tables, and I think they have this on the big periodic table that's hanging up in my classroom, but there would be numbers here like 1, 2, 3, 4, 5, 6, and 7. These would be called the period. So this number here, this number here, this is referred to as the period. And a period is essentially the row that goes across. So for period number 2 here, period 2 contains these elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Or period 3 has these 8 elements here, and then period 4 would have all of these elements here in this row. So when we're referring to periods, so if I say the elements in period 4, I'm saying this row of elements. But if I'm saying a group, that means I'm referring to a column of elements this way. Okay, so groups and periods, when we're talking about groups, we're talking about these. When we're talking about periods, we're talking about going across the periodic table like this. Now, some other patterns that we see within the periodic table, when we take the elements and we group them together like this, there's a lot of different patterns that show up. Now, the first thing is this, is that when we do this, what we actually notice is that the table actually splits up into kind of two sides. And so what I'm going to do here is I'm going to split the table up into its left-hand side and the right-hand side. Now you might be thinking that we're going to kind of cut it down the middle here, somewhere around group 8 or 9, right? Cut it down the middle, but that wouldn't be right. The actual, the halfway point, I guess we could think of here, and I'm going to get a different color here to do this, but the halfway point for the periodic table would actually be over here. I'm going to draw, it's kind of a staircase on the periodic table, and if I follow this line down like this, like so, all the way down to about here, this is actually the dividing line for the periodic table, or what we're going to think of as the dividing line on the periodic table, because elements like boron and silicon and arsenic, germanium, antimony, tellurium, Sometimes polonium is thought of as a metalloid, sometimes not. I guess it depends on the periodic table we're dealing with, but I guess we can include it just for symmetry's sake. Astatine. And we're not really going to worry about a lot of these elements down here. Most of these, especially these down here, we're just not really going to worry about them. I know they have names down here, but they're elements that exist for a couple of seconds in a lab and then they kind of deteriorate, and so we're really not going to worry about those for now. But anyways, this is going to be our dividing line. These elements actually make up the dividing line here between the left hand and the right hand side. And so on the left hand side would be starting right here, like aluminum, gallium, tin, bismuth, okay, these, and all the way over here, all of these elements on the left hand side, we're going to call this the left hand side of the periodic table, all of these elements would be considered metals. Metals. The metals are on the left-hand side of the periodic table. And when we say metals, we mean exactly that. Something that's shiny, is a good conductor of electricity, is very malleable. We can bend it, we can shape it. So, like for example, iron is a metal. We know that. And copper is a good example of a metal. Gold, platinum, and even things that you might not think, like calcium, for example, something that you might think of when you hear the term calcium, you might think, oh, that's like something that's in milk, right? But it's actually, and it is in milk, but calcium is actually in pure form. If we just had a chunk of just pure calcium, it would be metallic. It would be like a chunk of metal. Same thing with like sodium and potassium. All of these things are metals, except for our one exception. There's always exceptions to these rules that we have. Hydrogen. Notice that hydrogen, by the way, is a bluish color, right? On this periodic table, it's got a blue outline. That's because hydrogen really should be kind of over here on the right-hand side of the periodic table. There's a reason why hydrogen is kind of, we put hydrogen here. We'll get to that in the next video. But hydrogen is not a metal, even though it's on the left-hand side. That's kind of our exception to that rule. So if we have metals here on the left-hand side of the periodic table, that means on the right-hand side of the periodic table, anything to the right of this staircase here, anything to the right of that staircase, so all of this in here to the noble gases here, these are non-metals. Now sometimes I think students get a little confused here. When I say non-metals, that does not mean that I mean things that are not solid. So sometimes when I think students get a little confused, they think that these over here are all things that are solid, and most of them are. Like 99% of these things are solid metals. There's one notable exception, that would be mercury here. Mercury is a metal, but it's not a solid. It's actually a liquid at room temperature, which is kind of interesting. But over here with the nonmetals, now these, a lot of them are gases and liquids, but some of them are solids as well. So like sulfur, for example, sulfur is a solid at room temperature. Phosphorus can be a solid. Carbon can also be a solid, actually. So your pencil lead, which is called lead, it's not lead at all, but your pencil lead is mostly made of carbon, so it's solid carbon. But anyways, these are nonmetals, and so non-metallic things would be the opposite of this, which means they're not very shiny, they don't have luster to them. They're not good conductors of heat and electricity like these are. We can't bend them and shape them. Like for example, we can take copper and we can bend it and stretch it into wires and things. But if I were to take a chunk of sulfur and try to bend that and shape that into something, it would just crumble because they're very brittle. Same thing with carbon, right? Think again of the graphite or the pencil lead. If I were to try to bend that and shape that, it's very crumbly, it's brittle, it'll break apart. So those are the kind of properties that non-metallic things have. So along the dividing line here, so we've got non-metals over here, we've got the metals over here, And this dividing line here, things like boron, silicon, germanium, arsenic, and all these things, these we would refer to as metalloids. Metalloids. Metalloids are basically kind of like the name insinuates here, is that they have properties of both metals and nonmetals. So some of them are kind of have a luster or are shiny like metals. They kind of look like metals, but they don't really act like metals. A lot of them are kind of poor conductors. Like silicon, for example, is a very famous thing. It's what's called a semiconductor. It's used in a lot of electronics and things like your phone or computers because it's a semiconductor. It's kind of a good conductor, kind of not really, and so that's what these metalloids here along this line, they share kind of properties between the two. All right, so now that we've got that down, let's break down a couple more things. So on the left-hand side here, we said that we've got metals. Now, if we look, we can also group these a little bit further. We can get a little more specific. So these two columns over here, we could actually give these names as well. So this column all the way to the left here, these are called the alkali earth metals. Alkali earth metals, and these are called the alkaline earth metals. And then these all through here, all the way up through aluminum and through here. These elements in here, between our alkali and alkaline earth metals here, these are called the transition metals. Transition metals. And we could talk about the inner transition metals, which would be these yellow ones here. These are the inner transition metals, and then these other transition metals. But we're just going to say that all of these, so going from here all the way over to our staircase, these are called transition metals. And it's good to understand that, because as in the next video we're going to see, these transition metals kind of have different rules for their valence electrons and things like that. And then over here we can group these as well into some different things. So we've already talked about how this column right here, this column right here with argon, neon, krypton, helium, these are called the noble gases. We've already referred to those. This column right here, group 17, with fluorine, chlorine, bromine, iodine, these are a special group. These are called halogens. Halogens. If I remember correctly, the term halogen has to do with that it forms a salt. So, meaning salt forming. So if you think for chlorine, for example, when chlorine will bond with sodium, it creates table salt from that. And that's basically what happens with these halogens here, like fluorine, chlorine, bromine, and iodine. They like to bond with these earth metals over here, like lithium, sodium, potassium, calcium, magnesium, beryllium. And when they bond, when these halogens bond with these alkali and alkaline earth metals, they make salts, basically. And so that's where these get their name, the halogens, from. The rest of these, so this little section here, carbon, nitrogen, oxygen, sulfur, selenium, phosphorus, these would just, there's no special name for those. Those would just be other nonmetals, essentially, is what we would call those. So we've got noble gases, we've got halogens, we've got other nonmetals, which is just these, this little group of elements here. We've got the metalloids, we've got the transition metals that kind of are in the middle part of the periodic table, and then we've got the alkali and the alkaline earth metals over here. And again, remember, hydrogen is going to be, we would group with these other nonmetals with nitrogen and oxygen and such like that. So I think that does it for this video. I just wanted to make sure that we understand the basic setup. Oh, one last thing. This right here, you'll notice, and I didn't include it on the picture here in this video, but the lanthanides and actinides, those would also be, so remember that those two sections, those will show up somewhere beneath the periodic table typically. But the lanthanides and the actinides are those 14 elements in there that should technically be in this middle part of the periodic table. This whole thing should shift this way, but those are also just considered transition metals as well. Okay, so I think that does it for this video. In the next video, we're going to talk a little bit more about valence electrons.